Hi everybody, welcome to the last week for the pure organic chemistry. We're going to go through the last couple of years of exams, have a look at some exam type questions for organic chemistry that you'll be exposed to. And there's not a huge amount. It's often linked into the industrial chemistry. So I'm going to set up my whiteboard and I'm going to leave you guys with this question here to start with. Set up my whiteboard. So I want everyone to have a look at that. Have a think what you think the answer might be. Don't type in the chat yet. This could be really entertaining watching me do this by myself. So all the stuff on it for them. Get a charity event on the weekend if you want to order some new stuff in. What kind of reaction have we got for that multiple choice question? And give me an example of something we've looked at that uses that reaction. Put in the chat if you want to. Am I sharing the right document? We're about 50 of them open. All right, anybody got any ideas what type of reaction we've got here? Why isn't the chat showing up? So Jacob says decondensation. Do we have a protein or a carbohydrate here, or do we just have effectively ethene? So here we have, well, let's assume it's just ethene, and we're producing polyethene. What kind of reaction do we remember? Oh, my whiteboard's covered in sticky stuff. It's the formation of our plastic polymers. Jacob, you are correct if we were looking at a biopolymer, like a carbohydrate or a protein. Right. It'll be interesting to draw on. So we're actually looking at an addition reaction. So addition reaction, we're just adding monomers onto each other. If this was a whatchamacallit? If this was a biopolymer, like protein or a carbohydrate, it's a different paper. Got too many things open. We will be looking at a condensation reaction, but it's just basically looking, it just looks like ethene. So we have an addition reaction. So again, I want you guys to take 60 seconds. Hopefully it's fairly obvious what we've got here. Question 4. So with the multiple choice questions, you can see they're not that hardcore for organic chemistry. There's not too much they can do, and if you understand the basics, it should be pretty easy. So I'm going to give everyone 60 seconds to have a think about what that could be. That's going to look interesting on the recording. So what functional groups does oil of wintergreen have? 60 seconds starts now. Ross, I expect you to answer this. No pressure. So there should be one there that's in all the answers. That's so harsh. So have we got purely a ketone here? Or an aldehyde? So we've obviously got an alcohol functional group down here, but what's this? What's Cooch? COOCH. What's Cooch? Don't anyone say, well, I know you want to say. Out of all the functional groups, which one's Cooch? Here. So the C is coming off. Are you sure, Ross? It's got a carbon. So Cu, or COOH, is carboxylic acid. This would be named something propanoate. Actually, no. It would be named ethanoate. So if it's got Cooch, then it's a carboxylic acid. So all right, everyone's going to have 3 minutes to answer this. Actually, 2 minutes. Even if you just have a go at it. We haven't actually directly practiced this, but you should be able to put two principles together. So you remember naming the ethenes? For the enes, it's basically just naming an ethene, not an ethene, an alkene. And IUPAC rules are just how we name them. And this is the thing with the exam. You would not get taught directly how to name something like this in class. You'd be expected to have an understanding of organic chemistry and be able to apply that to the name that you're supposed to give us. And think back to your isomers because of this naming. And once I'll try redrawing it once we sure everyone's got 1 more minute. And I'll redraw it whilst you're looking at there, which might make a bit more sense. So we're gonna look at the whiteboard here, right? How many carbons are in the backbone? 5. So we have pent. Which carbon? You're right, Ross. I've added 2 extra H. I apologize. I did a 4-hour exam prep last year before the external exam, and in 4 hours I made one mistake, and it was exactly that, actually putting one, and someone picked up on it. For 4 hours I had to concentrate. And through the entire curriculum in 4 hours, someone picked up that I made one mistake, like Ross just did there. So we have pent, the pentene. It's coming off the second carbon. And on this one in particular, it's actually arranged like that, if we look at the picture. So if this is any molecule that's like this is an isomer. Any straight ethene molecule is an isomer, meaning this double bond can be anywhere. So we have to quantify which carbon it's coming off. We always count from the side that gives it the lowest number, 1, 2, not 1, 2, 3. We then have our isomer. Now you have to look at the hydrogens here. Are they on the same side or different side? So they're both on the same side. Now we're only looking at the hydrogens on the carbons with the double bonds. They're on the same side. So this is the cis isomer. If the hydrogens were on opposite sides, here and here, it would be the trans isomer. So we can already get rid of two of those answers. We can get rid of B and D because this is the cis isomer. And this is why I say it's not the smartest students that do the best in the exams. It's the ones that stop and actually look at the question and what's being asked. So we're now looking, it could either be cis 2-pentane, oh, sorry, pentene. Didn't think that would make it that easy last year. This is from last year's exam. I don't think they made it any easier for the students, but it was pretty easy. I don't know if they did that intentionally or not. So we've got A, which is cis 2-pentene, or we've got C, which is cis 1-ethyl 2-methyl ethene. Are there any side chains coming off this? So when we did it, and when you do it in class, you name it as pent 2-ene. But it can also be 2-pentene. Can be another way to name it. It's the cis isomer. So we would call it cis 2-pentene. Cis being the cis isomers, because the hydrogen's on the same side. 2, the ene group is coming off the second carbon. And we've got 5 carbons in the backbone. So Jacob, if the hydrogens are on the same side, on this double bond here, it's cis. If the hydrogen was on, if it looked like this, they'd be on, that would be the trans isomer. They're on different sides. All right. We didn't really go through fats because it's not a huge part of the curriculum. And so those who have done fats at school, I might send out a video on fats actually, so you guys go. Jacob and Lachlan, you probably won't have a huge knowledge, but again, remember what a saturated molecule is. So this question asks, this is an unsaturated fatty acid because it contains what? If you remember back to alkanes and what made our saturated hydrocarbons? Oh wait, whatever that is. So Jacob says A. So an unsaturated fatty acid has a double bond. Remember, we look back to our saturated hydrocarbons. They are completely surrounded by hydrogen, or they only have a single bond. This is an unsaturated fatty acid because it has a double bond as well as a carboxylic acid group. Now, and I've probably said that if you have a good knowledge of organic chemistry, then even if you're not 100% sure, you can still logically deduce what the answer might be. That's one of the very first things you learn in organic chemistry. What's a saturated molecule? This is unsaturated because it has a double bond, as well as the carboxylic acid on the end as well. But if it was a saturated fatty acid, it would only have single bonds. All right, I'm going to let you guys. So question 16, again, I hope this shows you that knowledge of the functional groups. Well, you know, you could have got 4 or 5 questions right just by knowing the functional groups here. So 2 minutes to have a think about that one. So have a look at the answers. Try and remember what the functional groups are and see if they match. So just wait, Jacob. Patience. Think about what a nitrile is. All right, well, 30 more seconds. So Jacob is correct. We have B. So we have a nitrile being converted into an amine. It's not a substitution reaction because we're not just substituting the nitrile group and the amine group. We're actually reducing the nitrile, or we're adding another covalent bond between carbon and the amine group. So we've done proteins. Again, I'm going to go realize how much time we've chewed through. 60 seconds for question 19. So Jacob says C. Jacob is correct. The primary structure is only down to the sequence of amino acids. Secondary structure is all of your hydrogen bonding between amine and carboxyl groups. Tertiary structure is when we start looking at all of the four intermolecular forces. Okay. Take a 30-second brain break and I'll get the next one up. All right, so now we're going to start looking at the short answer questions. All right, everybody have a look at that. And have a think about question A. I'm going to bring up the difference, and I'm not going to try and draw it because I'm conscious of time. So everyone, 60 seconds. What type of carbohydrate is glucose? So we've got, bring up the chat again. So our monosaccharides are glucose, galactose, and fructose. So glucose is an example of a monosaccharide. So question B. What is the difference between starch and cellulose? Think about their very basic organic structure. Yep. So Jacob says starch is alpha glucose, cellulose is beta glucose. That will get you 1 mark out of 4. Is that what I was sharing, or was I sharing the sample response that I'm not supposed to have? Were you looking at the sample? Was I showing you the sample response for the question? Whoops. Okay. Is there any other differences between starch and cellulose? Can you see the actual question now? Okay. Oh, that was good. Why do I keep doing that? Now I'm trying to bring up the notes. Now I'm a little confused. I've got 3 different screens going. Okay, can anybody think of any other differences? Think of, are they linear? Does one have chains? So I will show you, again, I'm not gonna try and draw. So a full mark if you drew something like this. Can you see the starch versus cellulose image there? So you can talk about the orientation of the CH2OH groups on the monomers. Starch, they're all the same side. Cellulose, they are alternating. So cellulose is a long chain polymer, but so is starch. But look at the orientation of the OH groups. So here, starch, the OH groups are all on the same side. Here, they're oriented differently. To get full marks for that question, you could explain that it's the orientation of the OH groups on cellulose that means we can't digest it. So full marks would be alpha glucose, beta glucose, as well as explaining the orientation of the OH groups. So you could look at starch is also You can have linear, you can have chains, and branches. So when you're looking at this, it's important to have a well-rounded knowledge of all these topics, because the more you can explain, the more likely you are to get better marks. All right, we're back to the questions. We're back to the questions. Someone let me know in the chat, because I can't see what you guys can see. Sweet. All right, I'm not going to look at any other questions aside from organic chem. Only one that matters. So we haven't done, this is organic chemistry, but it is in term 3. Right, another, if we look at the old one. All right, another paper. This one should take us to the end, I think. Okay. Go all see the 2019 paper. Sweet. Okay. Question 6. 2 minutes. What kind of organic molecule is this and why? So 1 more minute for everyone else. So Jacob is correct. It's a protein because of the R group. Also, we've got carbon to nitrogen bond here, carboxylic acid, and the amine groups. If it was a fat, it would look very different to that. Carbohydrate, again, would look very different. The R group is what gives it away as a protein. A huge amount that's accessible directly from organic chem. But It is intertwined into a lot of other topics. Okay, question 14. 2 minutes to name that one, and then we'll go through its name and why. All right, so this, anyone had a go at the naming in the chat? Why can't I see the chat now? So how many carbons have we got? Yep, Poppy's got it right. Classic methyl 2-butane. 2-methyl butane would also be accepted because we have a 4-carbon longest parent chain. The methyl group is coming off the 2nd carbon. Well done, Poppy. All right, 2 minutes. What is geometric isomerism? What is a geometric isomer? Okay, so geometric isomerism is like when we have our cis and trans isomers. So we have the same molecular formula. So we've got, again, in an exam like this, always give examples. So we can have, so if you drew an example like this, and you label this as your cis isomer, or your hydrogens are on the same side, and then you drew your trans isomer, with your hydrogens on opposing sides, and you said, hey, the cis isomer and the trans isomer have the same molecular formula. They are just arranged differently in 3D space. Cis, the hydrogens are on the same side. Trans, They're on opposite sides. Make sense? Good. Okay. Too many screens these days. So I want everyone. So this is everyone's going to have 3 minutes to answer this and justify why. And then we can go through the answer. And I think we'll leave it there because that's all the organic chem questions. Because it'll be a bit of a lengthy explanation. Right, 1 more minute. I want someone to have a go at it. All right, so we're looking at boiling points, right? So we're looking at intermolecular forces here. So hopefully you've written this down. So we've got propane, we've got propanol, and propanol. Right, 30 seconds. What are the functional groups present on each of these molecules? So propane, we've got carbon to hydrogen. Propanol, we've got carbon to oxygen. Propanol, we've got oxygen and hydrogen. So again, this is all down to intermolecular forces. Which of these three has the strongest intermolecular force? That will give you 1 mark. So we have dispersion, dipole, dipole. Here we've got hydrogen. So which of those three is the strongest intermolecular force? Sorry, can't speak at the moment. No one? So hydrogen has the highest intermolecular forces. So if you said they've got dispersion forces, dipole, dipole, and hydrogen, that'd be 1.5 marks. So dispersion forces is a weak dipole. It's fleeting. That's why it has the lowest intermolecular forces. Here we have a temporary dipole, semi-permanent, uneven sharing of electrons. And then for hydrogen bonds, he said permanent dipole, very uneven. Oxygen has non-bonding electrons, very strong bonds. And you rank them like that. One, the lowest, second lowest, highest. And you use those kind of justifications. That's how you would get the full 3 marks. Now, there's nothing in here and that we've gone through that you guys can't answer by having a really sound foundation in organic chemistry. That you guys did in week 2. You know, if you keep going over this stuff and you get a really good base, the exam shouldn't be that hard from an organic chemistry perspective. Thank you guys for this term. Apologies for the couple of weeks that were mucked up. It's been one of those terms. I will see you guys, I think most of you, if not all of you, are coming for next term where we're doing all industrial chemistry and some more hardcore chemical synthesis where we start making some gnarly organic compounds. Jacob, are fighting, so it's good to have on the recording. Just check the time and day. I think it's Tuesday or Wednesday. I think it's Wednesday, 8 p.m. I could be wrong. Tuesday, 8 p.m. I will see you guys there.